Alright, here in this lesson we're going to look at percents. There's multiple ways of looking at percent style problems. The way that I've found to be most successful for my Algebra 1 students is by using this formula right here. That some number A, or any number A, is equal to some other number B multiplied by some type of percent. Alright, now there's other ways of performing these types of problems. Feel free to read through the textbook section or ask me for additional ways if you are struggling after what you see here on the page. Something else, percents. We see numbers as percents, and we need to understand the exchange on how to go back and forth between decimals and numbers as percents. If you're a percent and you need a decimal, you divide by 100. If you are a decimal and you want a percent, you multiply by 100. And you'll quickly see that what this does is this moves the decimal spot 2 points to the left. This way moves the decimal spot back to the left 2 spots. And you'll see that pretty quickly after we even just perform this a few times on these percents and decimals. One last thing that helps people be successful is understanding this kind of language to where what is going to correspond to the missing variable. It's what's missing. Of is going to correspond to multiplication. And then the word is going to correspond to equals. Alright, so combining these three things that we've written out, we're going to be able to answer these questions, which can sometimes get overly confusing for people that haven't seen this stuff for a while or have never seen it before. It gets confusing on how to set it up. But using this formula and this language has been very successful for my Algebra 1 students in the past. Okay, example 1. What percent of 56 is 42? So here's what I see. What percent? So out of my formula, A equals P percent times B, it's telling me that the number I'm missing here, though, it says what percent is going to be that B value. So I'm missing, the P percent value. So what percent of, meaning multiplication, so of 56 is equal 42. So we're missing this percent component. It could be any variable. I'm going to use x. Now I solve for x like normal. I will divide both sides by 56. 42 divided by 56 is 0.75. Now the answer is asking for a percent. So I need to multiply that 0.75 by 100 or just recognize that it is 75%. So what that's saying is that 75% of 56 is 42. Alright, now that process may have been confusing to you, but once we do several of these, I think you'll pick up how to use the formula and how to set these up. And then it's just using a calculator and expressing your answers correctly. What percent of 90 is 54? So I'm missing the percent component of 90, so multiplication by 90 is equal to 54. This is the same setup. What percent? I'm missing this component of 90, right? So multiplied by 90 is, so equal to 54. I'll divide 54 by 90. I get a 0.6, right, after I divided both sides by 90. And then that 0.6, which you could think of as 0.60, when I multiply that by 100 is 60%. Right, it's a common misconception to call 0.66%, but that would be 0.06. Alright, now I won't fulfill every one of these, all three. I'll do 2 out of the 3. leaving you to have some to come back and practice on before you move on to the homework if you need the extra practice. Okay. So, this is another set. We're going to use the same language though. What is 32%? Now, I'm going to need that 32% as a decimal. It's going to be 0.32. So what is 32% of, so multiplication of 125? And so the unknown this time is what we're looking for. 32% of 125, so 0.32 times 125 will tell us our answer. So 125 multiplied by 0.32 is 40. So this answers the question. 40 is 32% of 125. All right. Now, I'm not going to worry about changing this one to a decimal or anything like that because there's the decimal component right there. We already used the decimal. This isn't going to be a numerical answer. You'll have to worry about switching it when the problem asks what percent. Then the decimal answer you get will need to become a percent. So this one here. What is, so unknown is equal to 0.35 of 80. So 0.35 times 80, 28. So 28 is 35% of 80, which should make sense because 35% is less than half. 50% of 80 is 40. 35% is less than 50, so our answer is smaller than 40. You can kind of check these to make sure that they're logical by applying that type of knowledge. Okay? So here it says 125% of what number is 17.5? So when this says is 17.5, that 17.5 is equal to, now 125%, it as a decimal, if you divide it by 100, it moves the decimal 2 spots. So this as a number would be 1.25. All right. Now, what 125% means is that we're going to take our number and increase it by 25%. If you think about multiplying by a 1, multiplying by 1 keeps us the same. But if I multiply by a 1 and 0.25, I'll stay the same and grow 25%. Okay, so back to the problem here. Here's the 1.25 multiplied by our missing number, which is x. I can solve here for it by dividing both sides by the number with x, and I will get that x is equal to 14. Okay? And this should make sense because it says what percent, well, 125%, sorry. Start over here. It says 125% of what number? That number is 14. So 14, when it's increased by a little bit, lands us at 17.5. Okay, let's try another one here. 30% of what number is 12.5? So it says is 12.5. So 12.5 is, with the equal sign, 30% as a decimal is 0.3 or 0.30 if you want to think of it like that. And then we're searching for that number. So I'll divide both sides by the 0.3. So 12.5 divided by 0.3. When I do it, I get on my calculator 41.666 repeating on and on. So I'm actually going to want to turn that into a fraction. And remember how to do that on your calculator is once you type in this 12.5 divided by 0.3, if you hit the math button, and then you hit enter on the fraction option, and then hit enter again, it will turn that 41.666 repeating into a 125 over 3. And that helps us address the fact that that decimal would be repeating forever and ever. Here's how you could check this answer. Make sure that 0.3 times 125 divided by 3 is 12.5. And if you type that back in on your calculator, you'll see that that is indeed the case. And all of these are checkable by plugging them back in as the missing link on the prior equation. So say right here, it says let's go back to this one we previously did and check it. What is 35% of 80? We said it's 28. We'd make sure that 28 is equal to 0.35 times 80. And if you calculate that, you'll see that you do in fact get 28 is equal to 28, telling us that 28 is indeed the correct answer. All right, real-world connection. We use percents so much in regular day lives, especially on sales, when purchasing clothing items or cars or consumables. There's often sales going on. Understanding percents are important because sometimes you think an item's going to be more or less expensive than it actually will be when you calculate your percent wrong, which can be embarrassing if you get up to the cash register. You thought a shirt was only going to be a certain amount, and it's way more because you messed up on the percent. Could be a little embarrassing there. So this can save you some embarrassment. Other ways that this has worked out for me is I knew something was on sale, so I have a rough estimation of how much it should cost. I'm up at the cash register, they scan it, I see the price up on the screen, and I know with estimation skills, hey, there's no way that's correct. Maybe it wasn't on sale in the first place and the price was more, or maybe they didn't type in the correct sale. When you get really good at percents, you can analyze pretty quickly, is something making logical sense? And I do that at the cash register all the time to make sure that I received the proper discount. Okay, so a dress shirt that normally costs $38.50 is